So our system is x plus 3y minus 4z equals 23. 2x plus 2y minus z is 19. And negative 3x minus 3y plus z equals negative 18. So our first method is this elimination method. In the elimination method, this first step is to pick a pair of equations and eliminate a variable. So basically, you have an x, a y, and a z. And whatever one you don't like, you get rid of. So of your x, y, and z, who don't you like? Z it is. In fact, as far as how to pick which variable to eliminate, as long as the coefficient's a 1 or a negative 1, it makes a good candidate. So notice x is 1 in the first equation, has the coefficient negative 1 for y in the last, and z has a positive and negative 1 in 2 of the 3 equations. So z is totally fine. So what two equations do you want to pick to eliminate z? Second and third. If we pick the second and third, what are we going to do to the two equations? Add them together. So your elimination method is also known as your addition method. If you want to be fancy, it's also known as your echelon method. I don't like that. So to eliminate two variables, you multiply one or both by a non-zero number so that when you add them, the variable goes away. We did not have to do that here because they're already opposite in sign. So if we add them together, how many x's do we have? Y's? These are gone. Constants? 1. All right. In step 2, we pick another pair of equations but eliminate the same variable. So we already picked 2 and 3, so we can pick 1 and 3 or 1 and 2. What would you like to pick? 1 and 2? Sure. So the coefficient of z in 1 is negative 4. We would need to make the z coefficient in equation 2 a positive 4. So when we add them, they go away. So what should we multiply the second equation by? Negative 4. Now you may have picked 1 and 3. You would have to multiply the last equation by positive 4 if that were the case. Your final answer will be the same. How you get there may be slightly different. So we're going to take this entire equation and multiply it by negative 4. Whatever you do to one side of an equation, you have to do to the other. You can have favorite children, but you cannot have favorite sides of an equation. So you distribute the negative 4 through. What do you get? Yep. Negative y, yep. Equals negative 76. Raise your hand if you know that you are your parents' favorite child. Correct. Good answer. Take that, sibling. If you're an only child, then. Hopefully that's true. How many x's do you have? Y's? These are gone. Constants? So steps 1 and 2, the whole process is to go from 3 variables down to 2 variables, which we did. In step 3, we take the results of steps 1 and 2 and eliminate again. So now looking at what we have, both x and y are going to be nice to eliminate because the results from step 1 had a positive y coefficient and a positive 1 y coefficient and a negative 1 x coefficient. So of those two, which one do you want to eliminate, x's or y's? Y's it is. What should we multiply the first equation by? 5. So in step 3, distributing that 5 through, we'll have negative 5x plus 5y equals 5. And keeping the results from step 2 the same, negative 7x minus 5y is negative 53. Add them together. How many x's do we have? Equals. So the reason we have to go down to one variable is because if we have more than one variable, we do not know any of the values for any individual variable. For instance, x plus y equals 5. Well, x could be 4, y could be 1, but x could be 2, and y could be 3. So there's infinitely many pairs of numbers in that case that would make it true. But once you get one variable, what does x have to be here? 4. So in step 4, solve for the remaining variable. So dividing both sides by negative 12, we get x to be 4. And now what we do is we back substitute, meaning we go to where we have just two variables and fill them in. For instance, let's use the result from step 1. So instead of negative x plus y equals 1, putting 4 in for x, we'll have negative 4 plus y equals 1. What does that say about y? Good. And now we have to find z. Let's use the last equation. Instead of negative 3x minus y plus z is negative 18. Uh-oh, squishy. We'll have negative 3 times 4 minus 5 plus z is negative 18. What do we get for z? 1. Step 6 would be to check your answer. You would plug in the ordered triple 4, 5, 1 into all three equations. Make sure when you check, you use all three. You may find an equation that works for one answer, not the other ones. Oh, it is negative 1 because we're adding 17. Thank you. Negative 1. So 4, 5, negative 1 into all three equations. I'm not going to require you to show the check. I'm just going to assume that everyone's going to do it. Okay. So your answer, 4, 5, negative 1.